Let us see phasor diagram and vector group of three-phase transformers. So what are the groups that for three-phase transformer? They are group 1, which belongs to Yd0, Yd0 and Dz0. Here phase displacement or phase difference is 0 degree. Phase difference is there. Group 2 is Yy6, Dd6 and Dz6. Here phase difference will be 180 degree. Group 3, that is Yd1, Dy1 and Dz1. Sorry, for zigzag it will be Yz1, and here it is 30 degree lagging phase. And group 4 is Yd11, Dy11 and Yz11. Here phase difference will be 30 degree lead. We will see all these phases, right? So for learning it, we must know some conventions. So what are the conventions? Conventions are, very first, that we will follow phase sequence as ABC. So phase sequence is ABC. That means it's A, it is B, it is C. We know phasor rotate in anti-clockwise, right? And HV side, second convention is HV side, terminal A to neutral, A to N is always vertical, is always vertical. Vertical means in terms of clock it will be at 12 o'clock or 0 hours. We will see clock system also for understanding these vector groups, and after understanding we will be in conditions to know which type of transformer will be connected in parallel for three-phase transformer, right? Third convention is HV line terminal of phase A, line terminal of phase A would be brought out from terminal A2, from terminal A2, right? So these are the conventions we will follow while drawing vector group. And what are these connections? So let me take any one connection, say Dy11. So this capital D represent HV side and this is small y represent LV side. And what this 11 represent? This represent that LV line to neutral, phasor is at 11 o'clock, right? That means it is HV line to neutral, and LV line to neutral will be at here. LV line to neutral. So these are the conventions, and if I use here clock system, so in clock system we will have first position, that is 0 hour or 12 o'clock, 11 o'clock, so it is 30 degree, and 1 o'clock it is also 30 degree, and 6 o'clock that will be 180 degree, right? So this is clock system 0 or 12. Now let us see these vector groups one by one. I have very first Yd0. That means primary is star and secondary is also star, but primary is HV and secondary is LV. So this is what 0 group, and 0 degree there will be the phase difference between the line voltages of primary and secondary. So for drawing its phasor, we must draw first line to neutral connection. So HV line to neutral, I told you that HV side A to N is always vertical. So HV, that is star, this is what HV line to neutral, right? Now LV is at 0 hours, that means it is in phase, so it is what LV, and its neutral is here. So phase difference is 0. Following this, I will draw first HV side terminals. So HV side terminal, say A2, third convention is HV line terminal of phase A would be brought out from terminal A2. So HV line terminal I am bringing, phase A terminal I am bringing from A2. So it will be A2 A1. Then following phase sequence I will have here B2 B1, and third will be what, C2 and C1, right? And this terminal is neutral terminal. So this is the HV side, and these are the terminals brought out: terminal A, terminal B, and terminal C. And we will write here arms also, that is branches. It is A arm or branch, it is B arm, and it is C arm, right? Because they will be helpful for drawing LV side or secondary side. Now terminal A and B, voltage between terminal A and B, if I use here star AB, so voltage between them will be line voltage, right? So I will write here VAB. VAB is the voltage which is line voltage for HV side. Now let us draw LV side. LV side line to neutral is also vertical. So LV side will be represented by small letters. So I will write here A2 A1, it will be B2 B1, and I will have C2 C1, and this will be neutral, right? This is terminal A, this is terminal B, and this is terminal C, and this A arm is in parallel with A arm of HV. B arm is this one which is parallel with B arm of HV, and this is C arm. So we have two terminals A and B, and voltage between them will be line voltage VAB. So what we are seeing, this VAB and this VAB, you can see it is VAB, HV side line voltage, and this is LV side line voltage. They are in phase. That is, phase difference between them is 0 degree. right? Now for connection we have to show 3 windings on primary and secondary, so I can show it here. So these are A2 A1, B2 B1 and C2 C1. These are the dots. So for HV side, A1 B1 C1 are connected to each other, so I am connecting them, and this terminal is what? Neutral terminal. And A2 B2 C2 are coming out as the terminals of primary side, so it is A terminal, it is B terminal, and it is C terminal. Secondary side is this is what? A2 A1, then B2 B1 and C2 C1, and these are the dots. And here also A1 B1 C1 are connected together, so this will become neutral of LV side, and A2 B2 C2 are coming out as terminals, so these are the terminals of secondary side A B C. So we will see remaining connections in a next video.